Hello, and welcome back to a special Calero Academy video.
We are happy to say that we are introducing a new model of Calero service.
We will be doing joint videos where we offer multiple approaches to very interesting problems.
So today will be the first application for this model. We will be fighting out a battle of the geometers, trigonometry versus no trigonometry. We're going to prove that the sum of alpha and beta in this diagram is equal to gamma here, which is obviously equal to 45 because of Pythagoras.
Okay, so over here me now. So, gamma is obviously equal to 45 degrees because we have an isosceles triangle and a 90 degree angle here. So gamma is 45 degrees. Now, a word about the setup of this problem. So we have three squares of equal length 1, equal side length 1, and we connect them all together, and then draw three lines from the upper right vertex to the three lower left vertices. Okay, so now we can get to the math of the first approach. So the fascinating thing about approach 1 is that the first approach is that it's very quick. However, the second approach, although it takes a little bit more time, is much more beautiful. So let's do the first approach. So we want to show that alpha plus beta is equal to 45 degrees. Now, proof. It is equivalent to show that tan of alpha plus beta is equal to tan of 45 degrees, which is equal to 1. Now, it's equivalent to show. So, all that we need to do here is expand tan of alpha plus beta. So tan of alpha plus beta is equal to tan of alpha plus tan of beta over 1 minus tan alpha minus tan beta. And now you might wonder, how are we going to get tan alpha and tan beta? Well, we just get it from this diagram over here. So tan alpha is going to be equal to 1 over 3, and tan beta is just going to be equal to 1 over 2. So tan alpha is equal to a third, and tan beta is equal to half. Plug that in, and we have that tan of alpha plus beta is equal to 5 on 6 divided by 5 on 6. Which is equal to 1, which ends this proof, the proof of this first approach. So, back to the other Calero headmaster.
So, now that we have finished approach 1, we'd like to show you approach 2. Now, the fascinating thing about the second approach is that we knew every side and angle, but we still could not find a way to relate the angles to the sides of areas without using trigonometry.
So the main ideas about this approach are going to be the unit circle and transformations.
So, here we're now going to demonstrate the proof with this diagram that we created before this video. Okay, so here's the diagram. We are hiding some of the diagrams for later use in the video.
Sorry.
Okay, so this is our so let's first start with drawing the unit circle around point A. Okay, and so then that creates, by construction, AB as the radius of this unit circle as a unit length of 1. And then we're going to draw, now we can unreveal this map, and we get that we can draw the tangent to the circle at point B, and then therefore the tangent will be perpendicular to the radius. Now, the next step is to extend the tangent at point B for 1 unit to point D,
creating a side of length 1.
Construct CD such that it is perpendicular to BD. And so now we have created it looks
So now we notice that AB is parallel to CD, and that AB is equal to CD, which is equal to 1 by construction.
Now comes the transformations. So we see that we can rotate our green and yellow triangles beta. So let's start with our triangle here. So we can rotate our green and yellow triangles beta degrees clockwise, like this, and then we can translate 1 unit towards A, and now we can reveal the rest of our diagram, which is just because we have
now we understand what the rest of the diagram is.
Because we have
so we just rotated the beta degrees clockwise and then shifted over 1.
Okay. So, now...
We can take this away now.
We can take this away now. So, so now we place our small 45-degree triangle in the left half of square ABCD here.
As shown.
Now, by rotating 45 degrees clockwise and translating up and left by 1 unit...
Translating this guy up.
Yes.
Translating this guy 45 degrees clockwise... rotating this guy 45 degrees clockwise, and then translating him up and left by 1, we have...
our desired construction, where the angle at A is equal to 90 degrees, which is equal to alpha plus beta plus 45
degrees. And here's the important part about this. Because before, we were not sure whether this 90 degrees was going to be equal, was going to have overlap, that it would truly be equal to alpha plus beta plus 45 degrees. But here, by sliding this triangle over and perfectly complementing this side, we have therefore proven that it is actually true that 90 degrees is equal to alpha plus beta plus 45 degrees, or that 45 degrees is equal to alpha plus beta, or that gamma is equal to alpha plus beta.
Yes.
And so, we'd like to thank you for watching this Calero Academy video special.
And we hope that this is the start of a whole new stage for the Calero Corporation. And so, as usual, we would be glad to help you with any of your comments or problems.
So, for example, if you have any comments, just put it down. If you have any comments, or if you would like to request for us to do a video of one of your math problems, just put it down in the comment section, or contact us at our Calero email. So, stay tuned for more Dual Caleros, and thanks again for watching.